Okay, look, let's face it. If someone gives you an equation that looks like this, so look at that one over there. So what is it? X minus 3 squared plus y plus 4 squared equals 25. You can immediately rip off, or whatever, the center and the radius of that circle. It's not a big deal. Okay, but what if someone took the equation for a circle and, with your back turned, actually squared out that first thing, squared out the second thing, and sort of scrambled the terms up, and then handed it to you? Well, if it's in that great form, fine. But if it's not in that great form, then you have something sort of scary. For example, look at this. Suppose someone handed you x squared plus 6x plus y squared plus 8y plus 9 equals 0. Now, if someone handed that to you, what would you do? Well, you'd hand it back, of course. But what if someone handed it to you and said, okay, that's some circle, and I want you to find its center and its radius? Not as easy if it were just given to you in that nice factored form. So how would you do this? Well, the thing to do is to try to take this complicated-looking expression and convert it into something of the form x minus a number squared plus y minus a number squared equals a number. And then you can read off h, k, and the r. So how do you do that? You complete the square, one of my favorite things. Now, if you want to review completing the square, you might want to click somewhere around me and actually do the complete the square little tour. But anyway, let me just give you a quick recap of how the completing the square system works. The first thing I want to do is keep all the variables on the left. Take any constants that may appear and move them to the right. Okay? All variables to the left, constants stay to the right. So in this case, I'd write the following. X squared plus 6x plus y squared plus 8y equals minus 9. Okay, now what I do is write the whole thing out again, but I'm going to put some spaces here. Remember what completing the square is all about. To complete a square, it means I have a piece of a square, and now I'm going to add something else to make it a perfect square. So I have x squared plus 6x, and then I'm going to have a plus blank, and then I'm going to write the rest of the stuff, y squared plus 8y plus blank equals minus 9 plus blank plus blank. Because if I add something to this side, I have to add to this side, and similarly here. How does completing the square work? Well, what I do is I make sure, first of all, that my coefficient on the square terms are 1. For example, if there was like a 2 here and a 2 here, I'd have to divide everything through by 2. Because to complete the square, I want to start off with a coefficient of 1 in front of the square terms. Happily, this is already just a 1x squared, and this is already a 1y squared, so we're all set. Once we did that, I then take a look at the coefficient on the x term alone. In this case, is 6. I take half of it and square it. Half of 6 is 3. If I square it, I get 9. And that's what I add here. So I add 9 here, and thus I have to add 9 here in order to make that thing, an equation, still true. I do the same thing here. I look at 8, take half of it and get 4, and then square 4, and I get 16. And that's the term I add here. Now, if I add 16 to both sides, I don't change the truth of this equality. It's still equal. But now, look what happens. This should factor to be a perfect square. And in fact, if you notice, it does. It's x plus 3 all squared. You can check that if you actually FOILed that out. You got to FOIL. X times x is x squared. Inside terms are 3x. Outside terms are 3x. That's 6x. And notice that 3 times 3 is 9. So that checks. And similarly here we get y plus 4 quantity squared. And that equals what? Well, minus 9 plus 9 is 0, and then I have a 16. So this really complicated looking algebraic expression can be massaged via completing the square twice into this form. Well, now it looks just like a circle form, and we can read it off because it's now of this nice form where you can see these numbers. So the center would equal what? Well, you may think the center is at 3, 4. If so, that's a great guess. But if so, then you're not quite remembering the formula for the circle, which is that it's going to be x minus h squared plus y minus k squared. So I have to write these things as minuses, which I do as saying x minus minus 3 squared plus y minus minus 4 all squared. And then it's more apparent what the center is. Center is at minus 3 comma minus 4. So in fact what I should say here is a minus 3 comma minus 4. And the radius? Well, the radius equals not 16. You may be tempted to say 16, but you have to take the square root of 16 because look at the formula over there. It's x minus h squared plus y minus k squared equals r squared. And so in fact I have to take the square root and I get 4. So the radius is 4, the center is minus 3 minus 4. I think this is really cool, by the way. That you can take sort of garbage like this and just by a little bit of completing the square, adding a couple things in, all of a sudden decode exactly that it's a circle, where the center is and where the radius is. I just think that's really cool. Okay, in fact I think it's so cool, I want you to have the thrill, the rush. It's sort of like, doing any kind of rappelling. Have you rappelled? It's just this great rush when you're standing on the edge of a cliff, And that's what you're doing here. You're sort of standing at the edge of the cliff of mathematics and rappelling. So how about x squared minus 4x plus y squared plus 12y equals minus 4. Why don't you try right now to find out where the center and what the radius is for this circle, which is sort of all camouflaged like this. Give it a try, and then we'll do it together. Okay, well, we have to do some completing the square here. So I already have the constant to the right-hand side, which is good. So what I'm going to do now is write this out as x squared, minus 4x, and then plus, and I'm going to leave a little space there. And then I've got plus y squared plus 12y plus, and I'm going to leave a little space, and then I have equals minus 4, and then a plus, and then a plus. Okay, what do I add in here? Well, I take a look at the minus 4 here. Notice I have my coefficients are 1 in front of the square terms. That's an important thing to check. I take the minus 4, take half of it, which would be minus 2, and I square it, and that would give me 4. And that's what I add to both sides to complete the first square, taking the part of the square that's given and adding the other part to make it a perfect square. And then here, I take 12, take half of it, which is 6, square it, and get 36. Excuse me. Once you get the hang of this, it's not that painful. Okay, and so what do we see here? Well, this should factor beautifully into a perfect square. That's the whole point. X plus 2 squared seems to work. And here I have a y plus 6 squared. You can check that, square it out FOIL, and you'll get this. And that equals, well, minus 4 plus 4 is 0. I just have 36. So the center is at minus 2, comma, minus. Oh, wait. There's a major typo here. Did you catch the major typo? I hope you did. This is wrong. See, this is actually a great thing for me to do. In fact, this was not an intentional mistake. But sometimes when you complete the square, you sort of feel so empowered. You're like, just moving along. I'm just moving. If this were a quiz, sure, I'd be moving, but I would have gotten it wrong. You know why? You have to be really careful. There's a negative sign here. So in fact, this should be negative. Right? FOIL it out. I'll get a negative 2x and a negative 2x combined to give me a negative 4x. With a plus sign there, I need a plus sign here. So actually, this was wrong. This should be a minus sign. In which case, if it's a minus there, this would be a plus here. So the center is at positive 2, comma, minus 6. Not negative 2, comma, negative 6. Great mistake. In fact, I proved that by actually making it live right for you. And the radius is equal to the square root of 36, which is 6. Again, you want to, go at a good clip, but you don't want to go so fast that you make sloppy mistakes, as I just did. But I caught myself by realizing that, wait a minute, there's a negative sign there that I never saw that sort of pop out here. And so I caught it. Try some of these on your own, and please don't make the mistakes that I make here. Have fun.